Okay, so today we're going to do 4.4 modeling with formulas. By the time you're finished this lesson, you should be able to rearrange a formula to isolate the variable that you're trying to solve for. So if you go to page 211 in your textbook, it's got a little definition for a formula, and we'll just write it down here. So it's page 211. So it says formula describes an algebraic relationship between two or more variables. And isn't that what we normally call an equation or a relation? So remember I talked to you about x equals 2y. That's an equation. It equates two variables. And then we had like x is greater than 3. That is a relationship. It's a relation between two things. It's not an equation because it doesn't have an equal sign. So really, aren't we just talking about equations and relations here? I would say yes, but what a formula is typically is something that exists a lot. That relationship occurs a lot, so we develop a formula for it. So you have tons of formulas that you already know, like the formula for the perimeter of a rectangle or the formula for the area of a triangle. Those are established and used over and over again, so we call those equations or relations formulas. Okay, if you flip your page in your textbook, and you can see that the steps are there in example 2 to rearrange a formula, which is what we're going to be doing today. So we're going to be able to rearrange a formula, and to do that you want to isolate the term that contains the variable. And then the other thing that you want to do is you want to isolate the unknown variable. Oh, goodness. Okay. So P equals 4S. Ooh, that sounds like the formula for the perimeter of a square, right? If I want to isolate for S, if I'm told what the perimeter is and I'm being asked to find the side length, then I would want to maybe rearrange the formula first instead of just sticking the numbers in and then isolating for S. So I would, over here I would say, okay, I need to isolate S, so I need to undo what's been done to the S. 4 is being multiplied by S, so the opposite operation of that, of course, is that we're going to divide through by 4 on both sides. And so S is going to equal P over 4. So now I have the formula in terms of the variable that I'm interested in solving for. Okay. Over here, we've got the formula for the perimeter of a rectangle, but it says it wants to isolate for L. So I'm trying to get L. I'm trying to get the term that contains the unknown variable, which is L, by itself. But there's something happening. There's two things happening to L. It's being W is being added to it, and then that whole thing is being multiplied by 2. So if we do our opposite operations in the opposite order, the first thing we want to do is get rid of that 2. So we're going to divide both sides through by 2. Let's see, what am I doing here? Equals 2 times equals W all over 2. So there I'm going dividing by 2. So then I have P over 2 here, and the 2's cancel, and I'm left with L plus W. And now we can see that the operation that's being performed on the L is addition of the width. So we're going to subtract the width on both sides. So this is going to be P over 2 minus W equals L plus W minus W. So that has the effect of isolating the variable on this side here. So L and P over 2 minus W is what the other side of the equation looks like. Okay? We're not getting a number here or anything. We're just rearranging equations. All right, A equals BH over 2. Oh, that's my area of a triangle formula. So I can see that if I'm trying to isolate for B, B's got two things happening to it. I've multiplied by H, and I've divided by 2. And it doesn't matter which order you do those two things in, the undoing part. So let's multiply both sides through by 2, because we were dividing by 2 here. So when I do that, I get 2A. And I don't have to put that in a bracket. I can just write 2A equals, and then again, I'm multiplying that whole right side here by 2. So 2BH all over 2. And of course, that has the effect of canceling those 2's out on this side. And I'm left with 2H over here. But I'm not done. I need to get B by itself. So now I have to undo what's happening to the B, which is multiplication by H. So I am going to divide by H on both sides. And then we end up with just a B over here and 2A over H. And you can't simplify it. We've got different letters. We've only got one number. So if we had multiple numbers, we could simplify those potentially. But this is all we can do. We've just rearranged the formula. We're not solving. We're not getting a number here. All right, so V equals pi r squared H. Oh, that sounds like pi r squared, the volume of a cylinder. So now we're going to isolate for H. So this one's interesting, because if we sort of deconstruct it here, we had the H. So now two things are being multiplied by H. The pi, which is just a number, 3.14, blah, 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 times r squared, okay, which is also the radius squared, which we don't know what the radius squared is, but it we'll leave it intact. So what I can do, in one quick step here, because all of this was being multiplied by the H, I can just undo it all by dividing through by everything that was being multiplied by H, on both sides, of course. So I've divided through by pi and r squared. And when I do that, I cancel all this, and I'm just left with H over here, and I'm left with V over pi r squared here. And I can't simplify it anymore. There's a lot of noise coming from my skylight up there. All right, so then I'm done. Okay. The formula for the area of a circle is A equals pi r squared, where r is the radius of the circle. Which of the following is the formula rearranged to isolate r? So I want you to try this, circle the answer that you think is correct, and then we'll talk about it. Okay, so I've got A equals pi r squared, and I have to isolate for r. So r has two things happening to it. It got multiplied by itself, and it's gotten then, after that, multiplied by pi. So the first thing I have to do is undo the multiplying by pi, because we're going in the backwards order, remember. So I am going to divide both sides through by pi, and that's going to give me just r squared equals A over pi. Now, squaring something, if r had was squared, in other words, r times r, then to undo that the opposite of multiplying something by itself is to take the square root of whatever that is. So I am going to take the square root of r squared. And of course, if I do that on one side, I have to do it on the other side. So I'm taking square root of both the top and the bottom, everything on the left-hand side. And so, when I take the square root of something squared, I just get what's under the radical sign without the squared part, okay? So the square root of r squared is just r, and this remains as the square root of A over pi. So which choice should we have made here? I think that's D. All right. The formula for the area of a trapezoid is A equals A plus BH divided by 2. Rearrange the formula to isolate H. Okay, well let's just take a second and look what happened to the H. It got multiplied by A plus B, and it got divided by 2. So if we're going to undo it, we can do it in a couple of steps. So let's just write it out. And I'm going to undo the division by 2 by multiplying this whole thing by 2 on both sides. And when I do that, I end up with 2A equals A plus B times H, because those 2's are canceling each other out. And remember, I don't have to distribute that 2 in there. This is just one thing here being multiplied by another, being multiplied by another. So I'm allowed to just cancel these 2's here. If this was plus H, then I couldn't just cancel the 2's, because the 2 would be being divided into H as well, so I can't cancel it. All right, so now I need to undo the multiplication that's happening here to the H, so I'm just going to divide both sides through by that A plus B on both sides. So this is going to end up being H. These cancel. Okay, A plus B divided by A plus B is just 1. So this is just H equals 2A over A plus B. Okay, I know that for some of you, because there's no numbers here, you're going to have some difficulty with this. But trust me, it follows the exact same rules that we've already been using to isolate variables. You just have to remember that you can't combine things that don't have like terms. Okay. The approximate number of pounds, P, in a kilogram is given by the formula P is approximately equal to 2.2 K. Christine's mass is 34 kilograms. Convert 34 kilograms to pounds. So we've got the formula pounds equals 2.2 kilograms, and it says convert 34 kilograms to pounds. So I am just going to write P equals 2.2 times the number of kilograms, which is 34, and P equals, where's my calculator? 34 times 2 plus 2. That's 74.8, and this is all approximate because that's an approximate formula there. 74.8 pounds. Therefore, Christine weighs 74.8 pounds. Okay, it says rearrange the formula to express K in terms of P. So we've got P equals approximately 2.2 K. I'm just going to divide through, of course, by 2.2 there and there. What we do to one side, we do to the other. I'm going to get K equals P over 2.2. So now I have a formula for K in terms of P. So if a question is given to me like C, where it says Catherine weighs 78 pounds and convert 78 pounds to kilograms, I already have it in terms of K. I'll just use this one. Again, this is approximate. And then K is going to equal 78 divided by 2.2. And these must be kindergartners, so don't weigh much. 78 divided by 2.2 is 35.5 approximately kilograms. Therefore, Catherine weighs about 35.5 kilograms. Okay, I think that's probably it for rearranging formulas. Yeah. Please remember don't do the homework for tonight's lesson. We'll do that in class tomorrow. Just go ahead and do the practice sheet that I put on the website. Thanks a lot.